What's up, everybody? We're on video 3 of air systems. The first two couple days, we've already talked about pneumatics. We've already talked about air conditioning. The next one we're going to talk about is pressurization. Again, going to try and make this one not really a too in-depth thing, but enough to where you understand the system and you kind of get what the lights, switches, and that kind of stuff mean. All right, so again, we're starting off in the cockpit of a 767-300. When we look at this, we have some rotary knobs that we can use for everything. Really, there are no switches. It's just rotary knobs. And one light, one gauge, and one window that has an altitude in it. So the pressurization system, if we want to think about this, it's not very complicated as far as a pilot's point of view is concerned. The big thing among most Boeing airplanes is works great, lasts a long time, and they're just done. They don't really explain anything else to you, and that's fine. Some people, if that's how you want to think about your systems, perfectly fine with me. I don't care. I just don't want to fly with you. But if we look at our cabin altitude control here, which is our pressurization system, you can see that there's not much that you can do from your side, right? You look at it and you're like, I got 3 switches or 3 knobs. Cool. So let's talk about what these knobs are and what they do. The first one is going to be our mode select. That's going to be this one down here. So as you can tell, we have 3 positions in the mode select. We have auto 1, auto 2, and manual. Now, think of these as individual motors because that's what they are. The outflow valve that's located on the left side of the airplane, back behind the left wing, just behind the bulk door, is controlled by one of these 3 motors. Okay, auto 1, auto 2 are both ran off of AC. Manual is ran off of DC. So manual is kind of like your backup, your non-normal, your nothing else is working, so I'm going to go to it kind of thing. Okay, above that we have our auto and op light. I'll show you what that looks like. Okay, we'll go into manual, and you can see the auto and op light comes on. Now, you might be thinking that it would come on anytime I lose an auto controller. And that's just adding logic and reasoning into something that's aviation related, and we all know that doesn't work. So in this particular case, what it is the auto and op light is going to illuminate anytime that we're in the manual position like we are now, or if we have a loss of the auto 1 and auto 2 controllers. And the reason behind that, at least, there's nothing written that Boeing says this is why, but the reason that I've deduced that this would be the reason as to why it's like this, and I screwed that up, didn't I? All right, is because auto 1 and auto 2 will automatically switch to the opposite controller if it fails. Okay, so if we're in auto 1, so if I can bring this back and go to auto 1, if auto 1 were to fail, auto 2 will automatically take over. That's what's supposed to happen, I should say. That is everything working as it should. Auto 1 fails, auto 2 picks up, and it continues to do its job. Vice versa. If auto 2 fails, and then it would automatically switch to auto 1 if I was on the auto 2 setting like I am here. Now, the great thing is if I continuously run it on one auto controller over and over and over and over again, which you won't do most of the time, but if you were, every time you land, every time the truck's on the main gear untilt or put you on the ground, it basically self-tests the opposite controller. So in this case, if I'm taking off in auto 2 and I'm flying my leg, I land, it self-tests auto 1 just to make sure that auto 1 works, because if it doesn't test it, you would never know. And the last place you want to figure out that it doesn't work is when you actually need it. So what a lot of companies do is they flip-flop, right? So I might use auto 2 on every even day of the month. and use auto 1 on every odd day of the month. I might switch it per leg. I might switch it if it's the captain's leg, it's 1. If it's the FO's leg, it's 2. It doesn't matter how you do it necessarily. Obviously, if your company has a specific way that they do it, follow that. But what we're trying to do, or what we're trying to eliminate, is the fact of overuse to where we wear one controller out and never use the other one. We do the exact same thing with the igniters. We switch the igniters from one side to the other for duty cycles to make sure that we're making that the two motors are getting the same amount of duty cycles on them. Okay. Manual, on the other hand, manual is used really in a non-normal situation. That's what manual is used for. It's if your auto 1 and auto 2 fail and you're losing pressurization at that particular time, then you're going to go to the manual position, and then you're going to try and manually take control of the outflow valve. Okay, now that leads us into this section here. So this section up here, I've got my valve position. So this is my outflow valve. Remember I said it's the giant hole you have on the left side of the airplane. This determines where it's located. So in case you didn't know, CL is closed, OP is open. Okay, and if you want to think about this, if you look here, closed, descending, meaning I am getting a lower cabin altitude. Open, I'm climbing, I'm getting a higher cabin altitude. So when I am in the manual position like this, what I have to do is I have to come up here, following a QRH procedure. I come up here and I bump this switch either in the climb position or in the descend position. Now look at what's happening with my outflow valve. Okay, so see how I hold it in one, it starts to open. I hold it in the other, it starts to close. So your QRH is probably going to say something like momentarily to climb or momentarily descend. You're going to bump that switch. I can't do it because I'm using a mouse, but you just kind of want to go like this and then like that, and then like this and then like that. And then you're like, how much is it opening? How much is that moving? And what I want to avoid is going, oh, like this, and now I've lost the cabin. Now I have no pressurization, right? Now everything's gone. Now I'm depressurized, and that's not good. I also don't want to hold it like this. If I hold it like this and that valve closes, what happens is that's going to drive my cabin altitude down, and it's going to drive it down to a point where, 1, it's probably going to hurt my ears. 2, I could overpressurize the airplane and I can blow out my positive pressure relief valves on the side of the aircraft. I've got pictures of those. I can show you what those look like. I don't have it on the actual side of the airplane. You'll just have to trust me that it's on the left side behind the left wing. Now, that is pretty self-explanatory, right? I go into climb, it moves. I go into descend, it moves. And that determines what my cabin altitude is in the manual position. Okay. Now, notice I go back to auto. It puts the outflow valve where it should for me to get whatever pressure I'm at this particular time. Now, over here on this side, I have auto rate, min and max. Okay. 50 feet, 2,000 feet. That's an approximation of what it is, but it's pretty close. So 50 feet per minute in a climb or descent is your minimum. 2,000 feet per minute is your climb and descent maximum. Then we have this little index marker. This little index marker, or caret, or indice, or whatever you want to call it, is where this is normally set. And this, being that it's a simulator, it doesn't quite go right on it. It kind of goes on one side or the other. But this is going to limit my climb and descents to 500 feet per minute in a climb, 300 feet per minute in a descent. So that will be the normal rate of my pressurization. Now, when it initially pressurizes, it follows how fast the aircraft is moving up until it gets to what it wants. And I'll show you that here in just a second. But it will pressurize the aircraft up until it hits its 8.6 PSI differential. and then it will go how it needs to, and it'll adjust how it needs to be able to keep that pressurization as you climb. Now, the other part, we got this landing altitude window. I've seen a couple different ways of how people set this. Just follow your company guidance. This is really just setting your landing altitude of wherever you're going, to your destination. In this, positive is to the right, negative is, or decreasing is to the left, and increasing is to the right. However, if I happen to be going somewhere that has a negative pressure altitude for landing, which off the top of my head, I can't think of anywhere that's like that, you would have to, on some aircraft, pull the knob and then spin the knob. So pull and spin to be able to go into the negative. Not every airplane's like that. Some airplanes you can just dial it down to negative whatever. But there are airplanes where you have to pull that knob and then turn it. And you can see that as I'm adjusting my landing altitude. Oh, sorry about that. Really? Now it's going to do that to me? Hang on. As I'm adjusting my landing altitude, you can see that the outflow valve moves. So the higher my landing altitude, the more open that valve is. And then the lower the landing altitude, the more closed that valve is. Okay. Now, I mentioned PSID. I mentioned that it's 8.6, right? So there's two numbers that are associated with this limitation in a 7.6 FCOM. Most of the time, I hate to do it, but I'm going to assume that your manual is very similar to the other two that I have worked with. And you're going to have two numbers in there. You're going to have the normal, and the max normal. Or the max and then max normal. They're written weird. It doesn't really make a lot of sense as to how it is. But that is our amber band and our red band here on the pressure differential gauge. So this is in PSI, but it's a PSI differential. Okay, so PSID is how you'll see it written. And if you look here, so this is 8.6 right here. That's where the amber band starts. The red band is at 9.1. Somewhere between 8.6 and 9.1, one of your positive pressure relief valves are going to pop. As you get above 9.1, the second one will pop. Again, it's aircraft dependent. Some aircraft have them installed that way. Some aircraft have them installed where they both go at the same time. It all depends. And the thing is you're not going to know it until you go and do your walk around after landing. That's just how it is. There's no indications. There's no way to fix it in flight. Nothing like that. But if you overpressurize the airplane, they pop out and then away it goes, right? So, again, 8.6, 9.1. It's usually in your limitation section somewhere. This middle gauge is going to be your cabin altitude in thousands of feet. So, 0, 2,000, 4,000, 6,000, etc. as you go around. And then here's my rate. This is my feet per minute times 1,000. So this is how fast my cabin is climbing if I have a decompression or depressurization, or if I'm losing the cabin for whatever reason. Maybe my autocontroller up here, maybe it faulted out on me. Maybe it's not working and it didn't switch over to Auto 2. Well, that'll cause me to lose the cabin. Maybe I'm in manual and I held this thing in open too long. Well, I'm going to lose the cabin. Speaking of that, let's check this and see how realistic it is. If I go to here, and if I go to climb. Nah, it doesn't. I thought it might move, but I guess it doesn't. You can tell that I do these with no script, right? I'm just kind of going through it. I want it to be as realistic as possible. I don't like to have the stuff scripted. I like to be able to do it just like I would do a class. So that's why if it seems like I'm fumbling around, it's just what I do. All right. So we've looked at the gauges, we've looked at these things, and we've seen kind of how they work. I am going to show you one other thing real quick that is on a PowerPoint that goes over the schematic of the pressurization system. Again, there's not much to it. There's two AC motors and a DC motor. DC motor moves a little slower than the two AC motors. The ACs are automatic. DC is manual. That's it. That's all there really is to know about the pressurization system. Hang on just a second. I'll get you over to the PowerPoint. We can talk a little bit more about that schematic. Okay, so now I've brought up the PowerPoint, and now you can see this breakdown or this schematic here of the pressurization system. So, if we look, we've got dotted lines that are going to indicate our manual side or our DC side. So that's going to be secondary in this particular case, because the auto is our solid line for the number one controller, because that's what we have selected to. So that means our secondaries are going to be these dotted lines here and here. Okay. Now you can see how Auto 1 and Auto 2 go into their own respective controllers. In those controllers, there's a lot of things that happen. We have air ground signals, we have thrust lever position, we have cabin pressure, we have barometrically corrected altitude. It has to take in all those considerations to determine how far it actually needs to move that actuator to move the outflow valve to determine how much air it needs to let out to be able to maintain that pressurization. Okay, so thrust lever position, obviously if we got more thrust, we have more bleed air, we have more air going into the packs, we have more flow coming into the aircraft, we can open that up a little bit more. If we're at lower power settings, then obviously we don't have the same amount of thrust, we don't have the same amount of bleed air, we don't have the same amount of stuff coming into the airplane. So that's why those things are important. Obviously, the air ground signal, that's tied into the self-test, right? So we talked about that if you're in Auto 1 and we land, it automatically tests Auto 2 and vice versa. That is the air ground signal. It has to have a way to know when you're on the ground to be able to do that self-test. Cabin pressure, that seems to be pretty self-explanatory. It takes the cabin pressure that we already have and determines what it needs to do to the actuator to keep us at that pressure. And then we've got the barometrically corrected altitude, which is really, it's just doing the corrections to make sure that it's doing it correctly in the controller to make these adjustments. But you notice what happens with the manual. It ignores all of those. So the manual comes up and around the controllers, and it's a direct link to the motor. So you are directly affecting that motor. Okay. So that is why I've done this in an actual airplane, not in a 7.6. I've done it in a KC-135, but I've had to run the pneumatic system manually. It is not fun. It sucks. It's a lot of work. And from everybody I've talked to in a 7.6 that's had to do this, they said you might as well have a third pilot do it because of how much time it takes, and especially if you're in a climb or if you're in a descent, you can overcorrect this thing easily. So just be careful with it if you ever have to do it. Again, follow your QRH. I can't say that more honestly. Okay, so that's the breakdown of the pneumatic system. Now, I told you I had pictures of the valves that kind of help. What I don't have is I don't have a picture of the outflow valve with me in this particular presentation. Just imagine it's a hole in the left side of the airplane behind the left wing. But on the lower cargo doors for passenger carrying airplanes, or for the main cargo door and the lower cargos for cargo carrying airplanes, they have what is called negative pressure relief valves. Okay, so if we need more air coming in, those valves will come in and allow air to come into the aircraft. If we have a negative pressure differential, it'll pull the air in, right? That is going to be on the main cargo door, the forward and the aft. The bulk cargo door is just a hatch, so it doesn't actually have any pressure, negative pressure relief valves on it. It doesn't have positive pressure relief valves either. It's just a door. These are your positive pressure relief valves. Now, the positive pressure relief valves, when you do your walk around, you're wanting to make sure that they look like this, that they're smooth, they're flat, they're against the aircraft like that, right? Because what happens is if you overpressurize the airplane, they will pop like this. They'll kind of butterfly out. So it's got this hinge right here in the middle, and it'll come out on the side of the airplane, similar to like that. And when it does that, they have to be reset by maintenance. That's nothing that you can do. You won't even, like I said, you won't even know that it happened until you do your exterior pre-flight, like your post-flight walk-around. Won't even know it happened. Now, if you come out and you see it, you're probably like, huh, that's probably why my ears hurt coming on the descent. Or, oh, I thought I held that switch in descend too long. Or close, or, however you want to say it. But that's what those do. And that's what that is. Again, that's kind of a quick way of going about it. If you have any questions about the pneumatic system, you can reach out to me. Or not the pneumatic, sorry, the pressurization system, or the pneumatic system, or the air conditioning system. It doesn't matter. Any of those, you can reach out to me at training@gsiguybrandon.com or gsiguybrandon@gmail.com. Those two are the only ones for that. And then, like I said in the last video, I'm putting together a website, and part of that website, I want to have a cool aircraft gallery picture thing. So if you have any cool pictures, if you have sunsets, if you have cool cities you flying over, I don't know, maybe you were in the military and you did formation flying, something like that, you can send those to info@gsigui.com, and I will put them up on the website to kind of show off some of the people that listen. I'm up to 92 subscribers now, so I've added 2 subscribers since the last video. If we get to 100, I'm going to do something. I don't know yet what I'm going to do, but I'm going to give away something. I'm going to try to, just to celebrate hitting triple digits. And then I'll do the same thing at 1,000, so on and so forth, if I get to that point. As always, like, share, subscribe. And let anybody know that needs any kind of stuff for the 7.6 that they can come to me. Outside of that, I'll see you guys on the next one. We're going to be going over equipment cooling, which I know everybody's excited about doing. But I don't care. We're going to do it anyway. All right. I'll see you guys. Have a good night.